Hey everyone, my name is Alex. Today I'm going to talk about how to prevent fragmented liquidity in your DApp. At Across, we have helped a lot of DApps basically with their cross-chain strategies by recognizing user balances across different L2s and then executing cross-chain transactions in one click. So I'll get into the details of that, but before, I just want to kind of talk through about myself. I've been at UMA and Across for over 3 years. During that time, I've spent a lot of time with UMA on the optimistic oracle. We resolve all the markets for poly markets, so we focus on prediction markets, insurance. But one of my favorite use cases is Across, where we essentially validate all the cross-chain transactions that Across does. So the thesis of my talk is just that we need cheap, fast, secure interop, so seamless you don't know you're using a blockchain. This isn't new. This is something we've worked on as an industry for years. And in some ways, with smart accounts, with chain abstraction, we're getting closer to this. But in other ways, we have DApps native to Ethereum or Arbitrum that are now moving to their own L2 or L3 with their governance token as their gas token. So in some ways, we're adding additional friction to the user experience. So it's going to be harder to have this native seamless experience. But before I get into that experience part, I just want to talk about the cheap, fast, secure interop, because a lot of times I feel like the front-end engineers or the UX designers are blamed for not having this great UX experience. But in reality, a lot of it is the underlying technology. We have to have really good bridges that are able to do transactions in 2-3 seconds for pennies. We can't be charging users $2 every time they're going cross-chain. So bridges need to be better. And this is kind of like the common way that people think of bridges today, where you have messages being passed from blockchain A to blockchain B. This is a common implementation, but there's many problems with sending messages between chains. It's slow, expensive, and insecure. We've seen countless bridge hacks, cost issues, and not to mention right now, the average bridge is doing $20 to $50 million of volume. And if we scale that up to in the billions, we're going to be sending millions of messages. It's just not scalable, and it's going to be expensive. So at Across, we really believe there's a better alternative, and that's cross-chain intents. We've been using cross-chain intents for the last few years, and it's worked incredibly well. So how cross-chain intents work, instead of sending a message between blockchain A and blockchain B, you have these, I don't know, my slide got messed up a little, but the solvers are watching blockchain A, and when they see basically an intent from a user, they compete to compete to fulfill that intent on blockchain B. And this is kind of like how the full stack of Across looks like. That intent layer, you have the user articulating their intent. It can be the same asset on blockchain A to blockchain B. It can be a different output token on blockchain B, or it can be as sophisticated as a user deposit into an Aave pool or minting an NFT. So once a solver sees that intent on blockchain A, they compete to fulfill the intent, and the user's happy because they're receiving that NFT, they're receiving that value on the destination chain in 2 seconds. But now you have the issue, they need to be repaid back. So how Across does this is we use our optimistic oracle to verify the cross-chain transactions and the intents have actually been fulfilled. And when they are fulfilled accurately, that's when the solver is repaid back with a small fee. So at the end of the day, you have the user that receives their funds extremely fast and cheap, and you have solvers that are fulfilling these intents and being paid back and making a good amount of money for fulfilling these intents. So this is just a quote I took. This is an aggregator that you're going 100 USDC from Arbitrum to Base, and this is being quoted for under 2 cents. And even though they quote us at a minute, I looked at our data, it's actually under 5 seconds for this route at this volume. So given that you can transfer value between different chains, different L2s in under 2 cents in 5 seconds, I would argue that we actually have fulfilled this cheap, fast, and secure interop. The problem is we still need the UX to be seamless. This is not a unique survey. A lot of the friction from the user experience is coming from poor transaction UX, onboarding, bridging and swapping, and just really abstracting away a lot of this complexity from the users. So this is really the focus of like what we're trying to solve. You have this user going to a DApp, and oftentimes they don't even know what contracts or what chain the contracts are deployed on. Once they figure that out, they usually have to switch their MetaMask to the same network. They realize they don't have funds, and then they have to go to like a bridge widget or maybe a separate bridge UI, bridge the funds, come back, and essentially refresh until their funds show up. This is a really poor experience. It's also requiring your user to know a lot of information. They need to know which bridge to use, sometimes the difference between wrapped and non-wrapped assets. So it's a really painful user experience, and for people coming into crypto today, they don't know all the information, and oftentimes DApps are missing out on users actually completing the actions they're intending to do. And then shifting over to just like a DApp developer, it's not like today they have a solution with no trade-offs. So these are kind of like the main solutions I've seen. A lot of DApps have decided to just deploy their contracts to every single chain. This might have been feasible a few years ago when 4 or 5 chains made up 90%, 95% of the total DeFi TVL. But today, that's not the case. You have hundreds of chains that are just going to keep growing. And then you also have the issue with fragmented liquidity, because I mean, we've all been to a DApp where there's the same asset on different chains with a different TVL and a different yield. It's super confusing for a user, and it's a lot to manage for the protocol. The other end of the spectrum is just deploying to one chain. So we've seen this successful with like Polymarket or GMX, and it can be successful with, if you're on a top TVL chain. However, when you kind of get to a newer chain that doesn't have as much TVL, or you're trying to bootstrap liquidity, it can really hurt by being siloed and requiring users to figure out how to get their money to your DApp. And then the last option is just becoming a cross-chain app. You can use like an arbitrary message bridge or some other solution. However, the trade-offs are, there's additional complexity, and also there's some latency issues. So what else is there? The solution we've come up with at Across is Across Plus, and this is basically easily allowing DApps to recognize user balances across all different L2s, and then basically being able to execute in one click a bridge plus action. So this is an example of a DApp that's integrated us. They're called Bazaar. It's a great user experience. You go to their DApp, you don't even know what chain they're on. They recognize all your balances, and I think the one really important thing to note is that this was no contract work. This is just a simple front-end integration that took less than a day to actually complete. So I think it's like a really good trade-off for DApps looking for some type of cross-chain strategy. So now I'm just going to run through kind of the steps to integrate this. The first step is just recognizing user balances on supported chains. This is not unique to Across Plus. Any cross-chain strategy, you're going to have to recognize the user balances. I just thought I'd throw that in there. The next is if you're an existing DApp and you have a contract interaction, such as an NFT marketplace where a user is sending money to a smart contract and receiving an NFT, you're basically just encoding this contract interaction into a message that can then be decoded by solvers and executed on the destination chain. So to kind of show this better, this is the full flow. So you have a user on mode, and they're sending basically the value to mint that NFT along with this message to an Across contract on mode. Solvers are then watching this, and when they see this intent, they're able to go to Linea and mint this NFT on behalf of the user. And once the optimistic oracle was verified that this intent was executed accurately, they refund the funds to the solver. So the user receives their NFT, the solver gets their money back along with a small fee, and this is incredibly efficient for cross-chain transactions. This could take under 2 seconds, and it could be pennies for the user, so it's a great trade-off, and we've seen a lot of success for DApps integrating this. And this is just a video of just basically it done in action. I think it's really cool because you don't even know, basically like what contracts the network's on. Every single chain is the same user experience, and it's very intuitive for the user. That's all I have. Thank you.